Welcome to Unit 6, Lesson 4. Today we want to take a deep dive into slope-intercept form. We mentioned slope-intercept form during Lesson 1. Slope-intercept form looks like y is equal to mx plus b. In slope-intercept form, that m is our slope, right? And in the previous video, it was called the coefficient of x. And then in the b is our value for our y-intercept, okay, or the constant will be our y-intercept. In the couple examples that you see below, we want to write the equation of the line in slope-intercept form. When the mathematicians were coming up with the name for slope-intercept form, they weren't super creative in coming up with the name. It's called slope-intercept form, and the name tells you exactly what that form provides for you. If an equation is written in y equals mx plus b, then the equation provides for me a slope and my y-intercept. If I have been given my slope and my y-intercept, then I can write an equation in slope-intercept form. So in number 1, it says that we have a line, and we've been told that it has a slope of 2, and it has a y-intercept of 6. We were given a slope and an intercept, so we're going to plug into slope-intercept form. My equation is going to say y equals, and in place of the m, I'm going to plug in my slope, which is 2. Remember, it is the coefficient of x, so y equals 2x. And then the plus my y-intercept, in this case, plus 6 is my y-intercept. In example number 3, if we think about what we were given, m stands for slope, b stands for y-intercept. So we have a slope here, we have a y-intercept here, and so we will plug into slope-intercept form. It says that y is equal to, I take my slope, 1/2 x, and then I take my y-intercept plus 1/3. Y equals mx plus b. In example number 5, that equation was not given to us in slope-intercept form. So we want to rewrite equation 5 in slope-intercept form. Notice that if we are in slope-intercept form, that y is by itself on one side of the equal sign. So we need to start isolating this equation so that y is all by itself. We did this in Unit 2 when we talked about literal equations. If I want to get y by itself, it is being multiplied by 3, and then 6x is being added to it. So the first thing that we would need to do would be to subtract the 6x on both sides. 3y is equal to, and then it doesn't really matter which order you write these things, but if we're thinking about slope-intercept form, then we know that typically the x term comes first, followed by my constant, which is a positive 10. To continue to solve this, we are going to divide both sides by that 3. On the left-hand side, the 3's cancel, and so we do officially have now our y equals. When we divide, we need to understand that we're dividing both the -6 and the 10 by that 3. So -6x divided by 3 gives us -2x. And 10 cannot be evenly divided by 3, nor can the fraction be reduced, so this is going to become 10/3, meaning that the slope of this line is -2, and the y-intercept is positive 10/3. On the next example, number 6, again, my equation is not currently in slope-intercept form. I do recognize that it already says y equals, so the y is by itself, but we have a little work to do on the right-hand side in order to make this say just mx plus b. So just 2 terms on the right-hand side. The first thing we need to do is distribute. The 2 is going to get distributed to both the x and the -5. Y equals 2x minus 10 plus 7. We should see now that when we clean this up, y is equal to, nothing I can do with the 2x because there are no like terms there, but what I can do is combine the -10 and the +7 because they are like terms to make a -3. y equals mx plus b, meaning that the slope of this line is 2, and my y-intercept, or where the line crosses the y-axis, will be at -3. Couple more examples here. In question number 9, instead of being given a statement or an m and a b value or an equation, we've been given a graph. In order to write something in slope intercept form, we need to know both the slope of the line and we need to know where that line crosses the y-axis. We need the slope and the intercept. To find the slope, we talked the other day in lesson 1 about being able to calculate rise over run. So I see a point on my graph of my line right there. And then I can see that the graph of the line also crosses at a nice point right here. If I calculate rise over run and put the slope information I learned in lesson 1 with this, then I can see that I rise 1, 2 units and I run 1, 2, 3 units to the right. So rise +2, run +3 makes my slope +2 over +3, or 2/3. I can also see that that graph crosses the y-axis right here. That is the point where the value of b is 2. We hit the y-axis at 2. And so we're ready to write our equation. Y equals m, which is 2/3, followed by x, plus my y-intercept of 2. Let's do one more like that. On number 11, again, we need to identify 2 points that are on our graph. If we take a look there, it looks like the graph crosses the at a pretty point right there. And then it looks like I probably have another pretty point, say, right there. Okay. If we calculate our rise and run, to get from the bottom point to the top point, I went up 1, 2, 3, so +3. But then I moved to the left 2 units, so that's a -2. So when I talk about my slope there, I rise 3, but I run 2 to the left, so -2. I can see that that line crosses the y-axis right here at -1. We are now ready to write our equation. Y equals, my slope is either 3 over -2, or I can call that -3/2. It doesn't matter whether the negative's in the numerator or the denominator. So -3/2 with my x, and then my y-intercept is a -1. Y equals mx plus b. All right, on the last one, number 10, notice that I have a horizontal line there. If we think about the slope of a horizontal line, if you're not sure, you could calculate your rise over your run. So to get from this point to this point, I had to rise 0, but I ran 1. And 0 divided by 1 is 0. The other thing I can do there is just understand that this horizontal line, I could make the letter Z out of that horizontal line. Z for 0. When I look at where that line crosses the y-axis, right here it crosses at -2. And so I'm ready to write the equation. Y equals my slope, which is 0, times x, plus my y-intercept, which is -2. Cleaning this up, I end up with the equation y equals 0 times x is 0, so y equals -2 is the equation of that line. All right, the next thing we want to talk about today is how do we graph lines in slope-intercept form? If we want to graph a line using slope-intercept form, our first step is to put the equation into slope-intercept form. Okay, remember that's the y equals mx plus b. The next step is that you are going to begin by graphing your y-intercept. If you'll remember, y equals mx plus b, your y-intercept was this b right here. I think of that b when I want to graph as the word begin. This is where I'm going to begin my graph. From there, you are going to move up from that y-intercept. You're going to move from that y-intercept up or down, rise, and then left or right to run. And that's going to give you a second point on your graph. You're going to repeat those steps again from the new point. You're going to go up or down and left or right using your slope to get a third point that's on your line. Remember that we are graphing a line, and so we want to make sure that we connect our dots so that we have a line, not just 3 individual points in the coordinate plane. Okay. Just going back to this real quick, I think of the M. Remember, we're going to move with our slope, our rise and our run. So I think of this M as the word move. So I'm going to begin with my y-intercept, and I'm going to move from that point using my slope. I've got 3 examples for you. On the first one, y equals negative 2/5 x minus 2. That equation is in slope-intercept form. Our first step is that we are going to begin by graphing that y-intercept. So if I think about where the y-intercept is, that is this number right here, my constant. So I'm going to begin the graph on the y-axis at negative 2. From there, I am going to move with my slope. My slope here is the coefficient of x, or the number in front of x, which is negative 2/5. And remember, we are going to rise and run with that slope. So from this green dot where I began, I want to rise 2. Well, that really means to go down. 1, 2. And then I want to run 5. If I'm going to run positive 5, I have to move to the right. 1, 2, 3, 4, 5. And there is my new point. I'm going to repeat those steps to get a third point on the line. So go down 2 and right 1, 2, 3, 4, 5. It's okay that it's off the graph. At this point, I have 3 ordered pairs that have been graphed, but I wanted to graph a line. So I need to connect those dots with a straight line. In example number 4, I should notice that that equation is not currently in slope-intercept form. So in order for me to graph it, I need to rearrange that equation so that it is in slope-intercept form. The first thing I'm going to do is to get the y by itself by subtracting 6x on both sides. Those cancel, so 3y is equal to, and then again, we typically write our x term first and our constant last. Next, we're going to get y by itself by dividing both sides by 3. And I have to remember both of these things are being divided by 3. Negative 6 divided by 3 is negative 2. Keep my x. Negative 9 divided by 3 is negative 3. And I now have an equation in slope-intercept form. I am going to begin on my y-axis at negative 3, or with my y-intercept. So 1, 2, 3. Then I am going to move with my slope. My slope here is negative 2. Right? If I think about that as rise over run, what number would be in the denominator of that negative 2? If you said 1, you are correct. So I am from this point going to rise negative 2, which means I'm going to move down, and then I'm going to run 1 to the right because that 1 is positive. And repeat, go down 2 and right 1. You're welcome to put as many points on your graph as you like, but we are going to require 3 points to make your line. Connect the dots, and you have now graphed. In our last example, y is equal to 1/2 x minus 4 plus 6. Again, this equation is not currently in slope-intercept form. We have a little bit of work to make it or rewrite it in that form. I do have y isolated, which is good. I need to distribute that 1/2 x to unlock that parentheses. 1/2 times x is 1/2 x. 1/2 times negative 4 is negative 2. And then I still have the plus 6. Combining my like terms, y is equal to 1/2 x plus 4. And we now have an equation in slope-intercept form. We are going to begin our graph on our y-axis at 4. And we are going to move with our slope, which is 1/2. Rise over run. So from this y-intercept, we are going to rise 1 and run to the right 2. Rise 1, run to the right 2. Connect your dots, and you've graphed the line. In summary, what 2 things will slope-intercept form provide? Remember, the mathematicians weren't very creative. They will provide a slope, and we will be provided a y-intercept.